This is section 5.1, perpendicular and angle bisectors. The first topic that we need to discuss when we're talking about this chapter is the concept of equidistant. Equidistant means equal distant, the same distance from a point. Okay? So equidistant means we're the same distance from a point as something else. And so when we talk about 5.1 and this section, it's all about being equidistant from things. The first way that we see this is in theorem 5-1. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So for example, if we look at point X, we would say that XY, the segment, is perpendicular to AB. And we know this because it forms a 90-degree angle. We would also say that segment YA is congruent to segment YB. That's what it means to be a perpendicular bisector, because it's perpendicular and it bisects. Okay? So the conclusion is that XA is congruent to XB because X is on the bisector. Okay? So because X is on the bisector and that's the perpendicular bisector, we can say that the two sides of the triangle are equal, okay, or congruent. The converse says this: if a point is equidistant from the points of the endpoints of the segment, meaning X is equidistant from A and equidistant from B, then we can say that XY is perpendicular to and bisects AB. So, because AX is congruent to XB, we can say that XY is a perpendicular bisector of AB, meaning perpendicular and bisecting. Okay? The next concept that we're going to explore is the concept of locus. It fits in with this because a locus is a set of points that satisfies a condition. Okay? So the perpendicular bisector can be called a locus because it's a set of points that satisfies a condition. Okay? Now, applying the perpendicular bisector theorem and its converse, we're going to find each measure. We want to find YW. Well, we know that because, and this is the Y, because XZ is congruent to ZY, and because WZ is perpendicular to XY, we know that XW must be congruent to WY. Therefore, WY, or YW, has to equal 7.3. So this must be 7.3 because it's a perpendicular bisector. Let's find BC. What do we know from this? We know that BA is congruent to AC And because of that, because BA is congruent to AC, we know that AD must be a perpendicular bisector. Therefore, two things happen. One, ADC, the angle, is equal to 90 degrees, and that should be the measure of ADC is 90 degrees. And two, BD is congruent to DC. So therefore, if DC plus BD equals BC, then that would be 16 plus 16 is equal to 32. So BC equals 32. The next one, see if you can do it on your own. I'm going to keep going on through it. So pause here if you'd like to do this one. What we have here is a perpendicular bisector. So RS of PQ. So therefore, PR must be congruent to QR. So the measure of PR is equal to the measure of QR, and when I substitute, I get 2n plus 9 is equal to 7n minus 18, and when I solve, I'm going to add 18 to both sides. And what I end up with is a fraction that is going to give me something over 5, 27 over 5, so that's going to be 5 with 2 left over, which is going to give me 5.4. Okay? They're asking me to find PR, and so PR is going to be 2n plus 9. I'll plug in 2 times 5.4 plus 9, which gives me 19.8. So PR is equal to 19.8. Okay? The next part. We've talked about perpendicular bisector. Now we're going to talk about angle bisector. An angle bisector bisects an angle in half. What we're saying here is if a point is on the bisector of an angle, point C in this case, then it is equidistant from the sides of the angle. So the conclusion that we can make when we know that APC, the angle, is congruent to angle BPC, we can conclude that AC is congruent to CB. The converse of this theorem says something like this. If we know that the point is equidistant from the sides of the angle, so we know that AC is congruent to CB, then we can conclude that these angles must be bisected. So this must be true. So angle APC must be congruent to angle BPC. Okay? We can apply these theorems in a couple of examples. In this one, we're finding the measure of LM. Because ray KM bisects angle JKL, we know that JM is congruent to, and that's a segment ML. Therefore, we know that JM equals 12.8, so ML equals 12.8. Okay? The next example. See if you can do this one on your own. We're trying to find the measure of angle ABD, knowing that these two things are congruent. ABC is 112 degrees. Because AD is congruent to DC, we know that ray BD bisects angle ABC. So therefore, angle ABD must be equal to 112 over 2, which is equal to 56 degrees. Okay? Last example. We want to find the measure of TSU. Well, because we know UT is congruent to RU, we know that ray SU bisects angle TSR. So therefore, we know angle TSU is equal to, that should be the measure, is equal to the measure of angle RSU. So we know 5Z plus 23 is equal to 6Z plus 14. And when we solve, we subtract 14 from both sides. We get 5Z plus 9 is equal to 6Z. We subtract 5Z from both sides. And what we end up with is we have Z is equal to 9. And when we plug that back in, measure of angle TSU is equal to 5Z plus 23, which is 5 times 9 plus 23, which would be 45 plus 23, which is 88 degrees. Nope, 68 degrees. Little angle addition error there. So 68 degrees. Okay, guys? So that's how this one works. We're going to have a second part to this video, which is going to be a coordinate plane type proof. Make sure you watch that one. This was part 1. We'll see you next time.